let's look at this graph right here, and I'm gonna complete it out on the board real quick. So we've got here to here to here. This is at 2, and this is at 3. This is at 1. And then we're here. We curve up to here, and then we curve down to here. All right. So we've already discussed that it's not continuous. F is not continuous at 1 because the limit is 2. F of 1 is 3, and 2 does not equal to 3. So this function is not continuous at 1 because f of 1 does not equal to the limit as x approaches 1. And then in part 2, we see that f of 2 exists, but the limit coming in from the left is 1. The limit coming in from the right is 2. So because the left-hand limit does not equal to the right-hand limit, then that means the limit as x approaches 2 does not exist. So this function is not continuous at 2 because the limit as x approaches 2 does not exist. So now we're on to 3. We said that we are not continuous at 3. So for what reason are y'all going to tell me that this function is not continuous at 3? And Sarah, I'm going to let you answer that one. F of 3 does not exist. That's all there is to it. The limit's fine, right? Your limit is 3, but f of 3 does not exist. Or you could just say f of 3 does not exist. So, are we good to keep going from here?
Yes.
All right. So now let's take this and let's look at this as far as equations are concerned. But I want to start off with piecewise equations, and then after we look at piecewise equations, which will probably take the remainder of class today, then we will get into other equations. So the first piecewise equation that I want us to look at, let's go with question number 18. And question number 18 says that we have f of x equaling to x squared minus 4x plus 3 over x minus 3 if x does not equal to 3. And if x equals 3, then we've got 2. And let me write these down again. F of c exists. The limit as x approaches c of f of x exists. And then c, the limit as x approaches c of f of x equals f of c. All right, so we'll start off here. Now, if you think about this function, if I did not give you this as a piecewise function to begin with, and I just asked you about x equaling to 3, you see that this is not defined at 3. Right? Okay. So just making sure we know that. But because I have this stipulation in here, now it is going to be. So I can say I know that f of 3 is 2. So it passes the first check. Now remember, for the limit, again, if we plug in 3 right here, I would have 9 minus 12, which is negative 3, right? And negative 3 plus 3 is 0. So I have a situation where I have 0 over 0. So there is the potential that a limit does exist. So let's see what that would be. So I'm going to take the limit as x approaches 3 of, and I'm going to go ahead and factor this out. It's x minus 3 times x minus 1 over x minus 3. Are we okay here? Okay, the x minus 3 is going to play with the dodo bird. So we're left with 3 minus 1, which is 2. So now we know f of 3 is 2, and we know that the limit as x approaches 3 is 2. So does f of 3 equal to the limit as x approaches 3? Yes. Therefore, it passed all 3. Therefore, f is continuous at